Belfast,
all the way.
all the way from Belfast to talk to us about tips for triumphant noding. I actually saw this talk earlier this week, and if you're doing Node in production or in any kind of way at all, there's absolutely fabulous stuff in here.
All right. So, I'd like to start off usually by asking how many people in the room actually work with Node, and then I usually try and tailor the talk, but this talk really does involve you working with Node. So, anyone not work with Node? Okay, okay, okay. So if there's anything in this that makes you go, what? Come talk to me at the end, and we'll head it out, and I'll try and make things clearer for you. Is that cool? All right. Cool. So, anyone recognise this sterling gentleman? See, this is, you have to be a certain maturity to know this is actually beyond my own maturity, beyond my own years. But I find him very funny. I used to watch. Does anyone watch the old Blackadders, the first Blackadders? He was in that as Richard III, just like a crazy guy. And he talks like this! Gordon's alive! And his name's Brian Blessed, and I feel that his blessedness will be on this talk. And I also feel that the word triumphant works with someone such as Brian Blessed. Okay, so here's the 10 tips. Develop debugging techniques, avail everywhere of the ecosystem, know when not to throw, reproduce core callback signatures, use streams, break up blockers, deprioritize synchronous code optimizations, use and create small single-purpose modules, prepare for scale with microservices, expect to fail, recover quickly. So that's me finished. I think Michaela's up next. Yay! Thank you. Again, if anyone in the room is this is a little bit too far for people, then come talk to me at the end and we'll go through details. I think we're going to be going out after this, aren't we? So we can always talk over glasses of some sorts of liquid. Okay, so the first tip, develop debugging techniques. So when I got started with Node, I had no clue about how to debug. I came from front end, so this is my debugging tool, console log, right? You stick it in there. Node has a built-in debugger. It's similar or inspired by LLDB, which is a debugger from C or C++, and it's not very fun. Show you quickly how it looks. Anyone used that before? Node space debug? Yeah. Got one? Got one, okay. Yeah, I will do. Let's get the code. What have we got here? So, my app. So, what is my app? Okay, so we got some stuff being done. So we say node debug my app, and then it will pause it at the first, pretty much the first call, and then you can have a look at the kind of options that you have. It's quite low level, so we can run the whole thing. We can continue from that point. We can say go to the next breakpoint. We can step through the code. We can come out. We can after a backtrace. One that's pretty good for getting context if you've done a little bit and you kind of lost your context, like sort of done something like that, and say list, sorry, call it as a function, and you can kind of see where you are, and then we can say step to the next point, and yeah. So this is one way to kind of step through the code, but particularly if you're coming from a C background, then this might be kind of comfortable. If you're coming from a front end background, it's not comfortable at all. So another option is Node Inspector. Anyone use Node Inspector? Same guy that used Node Debug. Miles. Good to see you. Okay, so Node Inspector, basically what it does is it installs this executable called Node-Debug, and that will, when you run Node-Debug with myapp.js, that will open Chrome and load DevTools, a sort of version of DevTools in the web browser, and then you can step through and breakpoint in that way. So, do I have it installed? I do. Is this going to work? Hopefully. Yeah, so you can see that it's paused on the same point. And again, the same way I stepped through last time, I can step through like this. Or I should have stepped into the shoot. Let's do that again. If I step into the function, there we go. And also we can get little pretty nice things. You can see what you have in the closure scope, and the local scope, and the global scope. You can kind of look through the stack. You know, all the things you can do with DevTools. What this lacks is, whilst this appears to be there, you can't do any profiling or anything like that. You can just do debugging. Though there is another tool for doing that. If you are interested in doing profiling, it's not on the slides. It's WebKit DevTools agent. You can check that out. And that gives you that missing functionality. Now, where did Brian go? Yeah, I think my talk is Brian. Okay, so. Okay, who's been doing Node more than 6 months? Okay, all right, that's good. Has anyone heard of the Node_debug environment variable?
Yep.
Miles, of course you have. Okay, that's good. That's good. That's more than in Waterford. So I hadn't heard about this until I started digging deep on debugging. Node_debug gives you basically allows you to turn on core debug logs, essentially. You can turn on FS/HTTP, NetTLS, module, and timers. So we have a server, and I'm going to have to edit my server here because it says Monster, which was the pub we were at. So I'm going to say, or just make it more general, a wider area. Okay, so I say node debug equals net HTTP node server.js. And you can see that there's a little bit of information come up there. What port was that on? 3000. So if I make a curl request, and then we can see some kind of information that's coming through. So from the HTTP logging, we can just see that the server had a new HTTP connection, that the outgoing message has ended. And from the net logging, we can see things like what the socket looks like once the connection closed. Yeah, some helpful stuff. One that's quite crazy is if I debug modules. Yeah, that one wasn't so crazy because I need an Express server really. Need something with more modules. If you're requiring a lot of modules, then you'll find that it's going to require Express here. So I need to install it. Yeah, so you can get a lot of output from that. And this is actually a surefire way to find out like what modules is the code that I'm running, what modules is it actually loading for real? Where is it loading them from? So usually you think, oh, I know, but it can be interesting to kind of analyze that just to make absolutely sure. Say you've got some weird esoteric bug and you really can't figure it out. You might find clues in that.
Hey, David?
Yes?
Just also, there's the request module from Miko. also supports this if you do node debugging as a request to get.
Oh, so he actually feeds into that environment variable. Very cool. That's really cool. So we'll talk about that a little bit. Basically, you can create your own behavior with the debug module, which might be what he's doing. Is it definitely node_debug or is it debug?
I'm actually using both at the moment, and it's different. It's so you get more like the one you're showing.
So you get lower level stuff with requests and higher level stuff with the debug environment variable.
Yeah.
Awesome. That's cool. So there's a debug module which pretty much allows you to do a similar thing but at a user level instead of like a core level. Basically you install debug when you require it, and then you use the return value from the debug module, which is a function, and you call that with basically a namespace. And that namespace in turn gives you another function which allows you to log things out. So we've got log info and error, all kind of sub namespace to the my thing app. If you had little lib modules that you were loading and things, you would say like, you know, my thing parser or whatever it is. So the way that we actually run that instead of node debug, we use debug. And I'll just get everything from my thing. So it's quite nice, color codes, different output. If I just wanted errors, then I would just ask for errors. The node_debug doesn't support wildcards, the debug module does. So you can actually get the default stack trace limit in Node is 10. So you can increase that limit because oftentimes you've got a dependency that has a dependency that has a dependency. You'll tend to end up with more than 10 frames to a stack when you get a stack trace. I believe the reason it's 10 is for performance reasons, and also like you don't want massive stack traces every time. But if you want to dig a little deeper into what's going on, then you can set the stack trace limit with the stack trace limit flag. So this code is executing, is evaluating the string, which is a function, and it's just basically it's just recursively calling the function 100 times until it tries to access a variable that's not been defined, and then that causes a stack error. So if I take this guy and execute him, and you can see we have the whole stack there. If I try and execute that without the stack trace limit, then we only get 10, and it's not very informative about where it's actually originated from, which was here. That makes sense? So you can also actually do this in process, which is nice. Couple of reasons you might want to do it in process. One, you can set it to infinity, which means you have unlimited stack traces. And two, you maybe have like a command line script or something, and flags don't actually get passed through to command line scripts unless you do special things to do that. So it's just like an easier way to turn that stack trace limit on if you just need a quick look. So, anyone heard of LongJohn? Miles hasn't heard of it. Anyone heard of LongJohn? Okay, so LongJohn basically allows you to have asynchronous stack traces. So in reality, the way that a stack works is it's within a certain event loop. So JavaScript goes around in a loop like this, and then there's an event queue that builds up, and it processes that queue, and then it goes on to the next tick. Whenever you make have an asynchronous operation, that is triggered in one tick and then processed in another tick. The callback is processed in another tick. So the triggering of that call and then the processing of the callback related to that call are in two separate stacks. And so you can have a stack trace, something's gone wrong, and there's only like 3 stack frames, and it's like, that's not right. Why am I getting a stack trace from a set timeout? Well, it's because it's asynchronous. So what LongJohn does is it actually provides the thread between asynchronous calls, and it basically shows you where that call originated from, which is really nice. So don't use LongJohn in production. Either remove it before production, or you could say like if process.env doesn't equal production, then require LongJohn. All you have to do is require LongJohn in your process, and you'll get asynchronous stack traces. So here we're evaluating a function that instead of just calling itself recursively, it's calling itself through setImmediate, which is an asynchronous call. Oh. Let me just install it, sorry. So in this case, we have each of the asynchronous hops being separated by dashes. You can also, in LongJohn, set the maximum. LongJohn has a maximum of 10 asynchronous traces, or asynchronous hops, whatever you want to call them, or frames. You can set that in the LongJohn module using LongJohn.async trace limit. So you can set that to a higher number, or -1 for unlimited. Okay. Okay, so this is something I wrote on the train on the way up. I call it Cube Stack, and it gives you nice stack traces. It gives you colored output, or tables, or JSON output. It also normalizes paths a little bit, makes them smaller, and then does something a bit weird with module paths to make them smaller. So here's an example. So that is basically if you want to have a look at that node example, is pretty. It just requires pretty and then throws x, which throw there doesn't cause a stack trace. It's x that causes a stack trace because x isn't defined. So it's a bit silly way to do it, but anyway, basically that captures the stack traces using something called error.prepare stack trace, which is a proprietary V8 function or API that you basically provide a function to error prepare stack trace, and you get the stack through as an array, and then you can do something with them. So here it is as a table. Oops. And you can see it kind of normalizes the path here, because usually it gives you the full path, but if your current working directory matches part of that path, then it will just kind of normalize it to a // so you get a slightly shorter thing. So it kind of lays out the information a little nicer. You can also make them longer. Here's a module throwing as a table. So what we do with modules is I put a little diamond in, because otherwise it would be node modules foo / node modules /var /node modules /bars /index, and like you're going way off for like something that's kind of like, yeah, I know node modules, okay? So in this module, the diamond represents the node modules folder. Yes?
Can I ask a question?
Yeah.
If you're using this on your web application, you get this, but what if there's an acceptance thrown in a different module or something?
Yeah, so this is an example of a sub-module throwing. So the throw actually happens in index.js of foo_bar_baz.
Okay.
So it works in, and here's another thing that it works with as well. So if I go in just to a REPL here and require QStack, we'll do a table again. And then I do a console trace. Still works. So it ties into, so it basically ties into, let me see, I've got like a bit of a plugin architecture going on, so you can create HTML stack traces and send them off somewhere if you wanted to. It ties into this error prepare stack trace. As I say, as a V8 method. it's a V8 API, and you supply it this method where you get the error and the stack, and we basically map through the stack. And when each of the frames that come through the stack have their own special API, which isn't really documented anywhere. You have to kind of look at the C code to find out what you can actually call. But you can do things like get the arguments, which I haven't put into the stacks yet, but you can get the arguments that were passed into a call, which you don't get in normal stack traces. The other thing that we do with this is if there isn't a function name, then it outputs the function signature. So then you still have like a good idea of what's actually happened. So let me do one of these old guys. So right at the top here, this function doesn't have a name, but we can see that's actually the function that Node wraps modules in. You can see it's got exports require module _ finding. And down here, right at the bottom, there's another function. So yeah, check that out. I think that's kind of an interesting thing to look at, because I wrote it. You can also have JSON output and pretty JSON output, and again, you could maybe pipe that JSON output somewhere else. So it could be used for, say, post-mortem analysis. You record your stack traces as JSON, and then you can create some kind of awesome web interface for looking through it like that. Okay, so function de-anonymizing, this is something I wrote as well, a little module. So you can have a stack trace, but if functions aren't named, you just get a bunch of anonymous functions. So you can have like a stack trace of 10 anonymous functions, you've got no idea what's going on, and you've got to look at every single one of those individually by line number and just kind of try and figure it out in your head. And it's not really a good sort of view into what's going on. But there's problems with the prevailing advice is name all your functions, and I'll tell you that, you should name all your functions, but then you have something like this, set timeout. What do you call that? It's just a little piece of work, a little thing you pass into a set timeout, and usually it's so generic you don't really have a good name for it. So the other point is that you'll often be working on other people's code and people don't name their functions. I sometimes don't name my functions, I forget. Or if I'm using a map function, when you're dealing with lambdas, which is using a function as a lambda, say passing it into map or for each or filter or reduce or anything like that, doing functional programming, you're really not thinking about naming the function. So what Decofund does is it basically names, it statically parses your code and then names functions according to the context in which they appear. So there's an example here. We've got a server running on Heroku. Don't be down. Don't be down. Good. And that is, you can pass any JavaScript library through this and it will work. So it names the anonymous functions in the actual jQuery library. So, so here you have jQuery function as var jQuery line 73. Function as property to array line 104. Let's see, what else have we got? I want to see one where there's return from a function. Here we go. Return function returned from create input sudo line 944. So basically, when you get a stack trace, you're like, oh, so it's returned from that other function that has a name, and you get a little bit more context about what's going on. So it's not just a server; it's a module you can download and you can use absolutely free. So here we have a file, and there's a couple of name functions, but it's returning an anonymous function from function A and function B, and we're also passing an anonymous function into a call to A. And in that anonymous function, we're doing console.trace. So I would then do, if I take a look at main.js, we require Decofund and we call it. and then we require anon. And then the anon file is automatically decorated with function names as it's being required. You can use decofun in other ways. You can use it as a, basically you load a file and then you just stream the file through it and it will come out the other end. So, oh no, you just pass a file into it, sorry. So I say node main. Well, let's do node anon first. So node anon, and you can see we've got some anonymous functions which are off the screen. Those long file names are kind of thrown off a bit. So anyway, I don't think it's even putting any function names out. It usually used to do anonymous functions. Maybe I'm using IOJS there, so it's maybe changed a bit. So when we run main, we can see that the function is passed into A line 4. There's a function returned from A line 10. A function returned from B line 14. And notice that there's spaces and pipes in the actual function names, but it's still executable code because those spaces and pipes aren't actually spaces and pipes. They're Unicode characters that are actually legal in JavaScript. So it's executable code. Nice, right? I thought it was nice. But that's not code that you would write necessarily because it's hard to work with code like that. So you just leave it anonymous and then it does that for you.
Would you have this in production?
Are we using it in production?
No. Would you leave this in production? Would it impact?
I don't necessarily think you'd need to. If you need to debug something in production, you can always just throw that in there, and then you get your traces. You just kind of throw it in and take it out. Yeah, I mean, yeah, I don't know what the implications are of having like Unicode characters. Like, so for instance, particularly if it's a script you're delivering to a client and it's an old IE client or something, it will choke on the Unicode characters. Probably. Okay, tip number 2. How are we doing for time? Avail and beware of the ecosystem. So here we have Brian saying, avail! And so, everyone knows about NPM, right? Mm-hmm. Okay, use it. Beware! So anyone can publish anything to NPM. You've got to learn who to trust, figure out who's trustworthy in the ecosystem, how many other modules depend on this module. That's a good thing to look at. Does it have a shiny website? That's very important. It's actually sometimes not a good thing, because if you've got 1 or 2 developers working on a module and they've got an amazing website, maybe they should have been working on the module. If it's a big company, fine, but some of the modules are actually really well written by like just 1 developer. Node.js.com, excellent resource, pulls a bunch of metrics from various sources to provide a confidence level for a module. So it pulls metrics from GitHub and different places to work out, to try and provide a better confidence level. So Node.js.com. Global modules, npm g install, are you crazy? So how many people install modules like a global module using sudo? Yeah. See, because we don't think about it, but the thing is you're installing something as root from essentially an untrusted source. And some of the reason it has to be sudo is purely because it's stored in user local bin. So we can fix that. It's only occasionally necessary to have something in user local bin, or to have root privileges for a module. So the N module manages Node versions. It would need root permissions to install versions of Node, so we'd have to run that with sudo. And if you run it with sudo, then root only has certain paths that it has access to. You could change that, but you don't really want to get messing with that. Phantom.js also needs to be run with root permissions. I don't know why. Okay, so the way you can fix it, and these slides are online so you can see this. I'll tell you where they are at the end. You make a folder in your home directory. You say npm set prefix to that folder, and then you add that folder to your path. And now when you install a module globally, you don't need to use sudo. And then if you have a multi-user system, everyone has their own set of global modules. For edge cases where things like n need to be ran with sudo and they need to be in user local lib, just set up a soft link from that to the home directory. Except in a multi-user system, in which case you might want to like copy it over or something. Okay, know when not to throw, or when to throw. So when to throw? Throw to flag developer error. Someone is using your module's API incorrectly. Throw from the command line or build tools if necessary, which is kind of equivalent to developer error, so they've used your tool incorrectly. When not to throw? Don't throw from a service. Never throw after initialization time, that is. Never throw because of bad config. Notify and revert default instead. Never ever throw in an asynchronous context. If you throw and you use it, one of the reasons you don't throw in an asynchronous context is because try-catch can miss asynchronous operations. It can miss them out. So you can't even catch that, so your server's going to die. I won't say that. Okay, so alternatives to throwing is debug log output, DevOps alert systems, kill process and restart, which is perfectly fine if you're not running a monolith. Why to not try catch? Yeah, not asynchronous. Also, it's a V8 optimization cluster, so if you absolutely have to try catch, isolate that try catch in its own function, and then you'll allow V8 to actually optimize the function that it otherwise would appear in. When it might be useful, if you're doing a JSON pass will throw. If it's not valid JSON, so if you have user JSON input, then you might want to put a try catch around that, and then you'd isolate that in its own function. You could also, there's maybe a use case for try-catch for detecting certain ES6 features. So let is an ES6 feature, so we can basically try let equals foo and eval that, or using the function constructor to do it, the same kind of thing, and then set let support to true or else caching it. So then let support will be undefined, and if it's undefined then it will load the transpile mod. If it's true then it will load the ES6 mod. There might be better ways to do it than that. Reproduce core callback signatures. So most people, if you're using Node in here, you'll know this one. Error backs, error first callbacks. If you're creating an API with callbacks, you want to mirror the way core works, because then we'll sing off the same song sheet, right? The reason you want error first is because it forces the user of that API to consider the fact that there may be an error. If you put error second, they can ignore it. So here we have concat string to file, a little function that we made that calls fs exists and then calls fs read file. They propagate the errors up through the callback, and then in our final user side call, that's where we handle the actual error if there is one. Use streams. Has anyone heard of streams? Anyone heard of streams? Okay. Good. So, in a node process, you don't want to buffer everything into memory and then process that. It's not how JavaScript's built to be worked with. It's also, if you've got a lot of data to pull into that process, you can't do anything until all that data's in. It'll also block your event loop. So if you're doing anything else in that process, then it's going to have to wait, including client requests and responses. So this will request all of the modules on NPM and their version history as JSON data, and then try to parse it. On most laptops, that just falls over and dies. This uses streams to incrementally process the data. Here we use JSON stream. So request returns a stream, we pipe it through JSON stream, and then we just get the name from each module, and then add a new line, and then pipe it to process.std out. And that will actually pipe through the names of modules immediately, whereas the other will fall over. There you go, straight away. Whereas the other one will block until it's loaded all the data, and then it will probably fall over before that, and then it would output the thing once it's processed it all. Okay. I'm not going to talk about all that, but I do want to talk about the FullStream module. The FullStream module is really nice. It's by Dominic Tarr, and basically it's a very minimal implementation of streams. The reason this is good is because if you browserify some Node code that has streams, it'll add 100K to your client-side code. I don't know about you, but I don't want to add 100K so I could use a stream. FullStream has pipes, just the same way that Node streams have pipes, but it uses really simple function recursion to do it instead. I mean, it's really small, it's like a couple, like 2K. So then I built something on top of that called WebSocket FullStream. There's something called WebSocket Stream that clocks in at 200K for client-side code. WebSocket FullStream comes in at around 15K. gzip to minified is less than 3K. So it also has a bunch of other cool stuff that WebSocket Stream doesn't. For instance, you can pipe objects straight into the stream on the node side, the server side, and get objects out on the client side. It has multiplexing built in, different things like that. You can also just pipe, on the server side, you can pipe node streams into WebSocket FullStream. It'll convert them to pull streams before they go across into the client. So you can use WebSocket FullStream, use node streams on the server, pull streams on the client, and save yourself like 180K's worth of code. So it's worth checking out, and I really do believe that, and it's also because I wrote it, but it really is worth checking out. Okay, breakout blockers. So the event loop at Anthos Node is single-threaded. The thread is a loop which processes an event queue. Each item in an event queue is added to that queue in a previous loop. I think I explained that earlier. So here's a simple way to self-deny a service attack yourself while one. Examples of blocking code is like a hashing function, JSON passing a huge string, any of the sync APIs. Always prefer non-blocking logic in an asynchronous environment. As soon as you use synchronous blocking logic that takes more than more than 100 milliseconds or so, you're degrading your service. You're degrading your processor's ability to process anything else. So how do you fix that? What if you have to use something synchronous after initialization time? Use separate processes. You break blocking code out into separate processes, communicate asynchronously with the process, and so now this new process is a service for your app. This little worker that you spin up and you can communicate with asynchronously. Your main event loop is left free to do the important stuff. Deprioritize synchronous code optimizations. Just going to let that sink in. Deprioritize synchronous code optimizations. So I was thinking maybe some of you maybe make that face when I said deprioritize synchronous code optimizations. Asynchronous operations take much longer than synchronous logic. The asynchronous part is the bottleneck. If you focus on optimizing async code dependencies, like running independent operations in parallel, choosing endpoint systems that can combine operations, then your time is way better spent. Synchronous logic takes a really long time, as I said. Don't focus on trying to optimize that, micro-optimize it, break it into a separate process. There is a place for optimizing synchronous code, but you've got to measure the cost-benefit of that. So, for instance, Lodash. Anyone heard of Lodash? Anyone heard of underscore? Lodash is like a faster underscore, it's better. It's well written, and it's really optimal synchronous logic. And the benefits are magnified because it's open source and has a large audience. So his work as a developer is worth doing those synchronous optimizations because of the impact of the code. Also, because potentially large amount of data could be passed through Lodash. Optimizing hot code could be worth it, so you've got a function you know it gets hot, but V8 tends to optimize hot code very well. So before you start optimizing some hot code, make sure that V8 isn't like doing it for you and you're just wasting your time. Ways that you can actually figure out what V8 is actually doing with your code is to use things like trace inlining and trace deopt. You pass those flags with Node, and it will tell you if it's inlining functions, if it failed to inline a function, and it will also tell you like other kinds of de-optimizations. You can also trace opt as well to trace optimizations. So you can use those flags to basically, if you know you've got some hot code that's being hit a lot, use those flags and see if it's being inlined or if it's failing to inline. If it's failing to inline, then figure that out. That's worth doing, probably, with hot code, because you want it to get inlined. By inlining, I mean that basically V8 will take the machine code and literally stick it in a block of assembly code that will just keep getting hit, instead of having it jump around. Use and create small single-purpose modules. Is this new to anyone? I don't think this is new to anyone, is it? Use and create small single-purpose modules? Yeah, so do that. Prepare for scale with microservices. Anyone heard of microservices? Richard Rodder's been here, hasn't he? We're actually having a microservices meetup. Is it next month?
Yes, 24th.
24th of February next month, which is 2 days before the Node meetup. So if you want to know more about, like, dig real deep on that stuff, that meetup is the place. So most people know about microservices. Basically, a good way to describe a microservice is by juxtaposing against a monolith. So a monolith application is one where all or most code is running the same process. Potentially fine for certain scenarios. So software products. Okay, you can do that as a monolith, fine, doesn't matter. But when software as a service, monolithic architectures can be problematic. If a monolith dies, everything dies. All of your service dies. Monoliths have a glass ceiling when it comes to scaling. At some point you've got to break them up, or you've got to duplicate, and you've got a lot of redundancy and stuff. Also, JavaScript is designed for large-scale monoliths. Large class hierarchies are a code smell, throwing kills the process, native runtime throws, processes can die really easy. So, microservice, you break out, when we broke out that blocking piece of code, we were talking about that, that's essentially creating a microservice to do something. But you also tend to split up microservices by, like, business areas. So basically you split it all into little pieces and they all talk to each other. That's microservices. But go to the meetup, I think there's more to it than that. Different ways of communicating. Anyone heard of Docker?
Yeah.
It's awesome. Basically it gives you a virtualized contained environment without the cost and overhead of using a virtual machine. If you've not heard of Docker, check out Docker. It really is very, very cool. And so you basically can wrap each microservice and maybe a database that it's using in their own virtualized container that's basically segregated from everything else. And when you do that, you feel like this. It really is good because everything's smaller to deal with. Like here's the definition of a microservice. If you can fit all of the code into your head, then it's small enough to be a microservice. If you can't, then it's not. Expect to fail, recover quickly. So whether running one process or many, expect to fail. Expecting to fail leads to robust, high resilience deployments. Expectation of failure makes monitoring, notifications, and failover non-optional. So when you can create a culture in which everyone's expecting things to die, you create a much more robust system. So using a chaos monkey embeds failure expectancy into a team's culture. Anyone heard of a chaos monkey? Okay. Anyone not heard of a chaos monkey? Alright. So Netflix came up with this concept where they have a service that goes around and randomly unplugs servers. That's what it does. And that runs every day in production environment. So when they create Netflix do a microservice kind of architecture. When they create new services, they basically are so aware that it's definitely going to die that they put in the right kind of things to take care of it. So a couple of years ago, Amazon Web Services had a complete blackout. A lot of services went down, a lot of big services, a lot of big websites went down. Netflix did not go down, even though they used Amazon Web Services. They didn't go down because they had all of these contingency plans in place. They've now taken it and extended it, and they have a Chaos Gorilla, and the Chaos Gorilla unplugs entire data centers from time to time, or in so. That's fine. Recover quickly, you can use these tools forever. Node-based tool that keeps the process alive. PM2, another keep alive tool with additional features like clustering and load balancing. Upstart is a kernel level tool bundled with certain Linux distros like Ubuntu. You get higher quality monitoring in the unlikely event that Upstart fails. It causes a kernel panic and the whole server must restart. So with Forever and PM2, they're node processes. If they die, your monitoring dies. With Upstart, it's a kernel level process. If it dies, your server's dead and it'll have to restart. So it's a much bigger deal. And it doesn't tend to fall over. So something like Upstart is a good choice. Monitoring tools that work at a kernel level, good choice. Uptime Robot and other services like that, they'll ping your URL every 5 minutes and then email if they don't get a response or text you. Those can be helpful, even for personal projects. Uptime Robot's great because it's free, but there's enterprise versions of the same thing. Nscale, anyone heard of Nscale? Yeah. Nscale does entire deployment monitoring. So it will monitor virtual machines, containers, remote servers, Amazon Machine instances, so on and so forth. You basically describe to it, this is how my deployment looks, and then it can basically compare your live running deployment to what your deployment is supposed to look like. And if it's not what it's supposed to look like, then you can say it's NSD system fix, and it will generate the commands and then run those commands to bring your deployment into line. Really, really nice. It's got some other cool stuff as well, like version history and revision control on your entire deployment stack, not just a single thing. Avoid downtime, use failover to avoid downtime, spin up multiple instances, and load balance. Nginx works well as a reverse proxy. Finn? Okay, so, is the pizza here yet? Okay, well I'll just, that's not going to work. I'll just finish with this video of Brian Blessed, and then
Yeah, they're here.
there's the pizza. Thanks everyone.